Welcome, everybody. Good afternoon. I'm Pat Patterson. I'm a technical director at a company called StreamSets that I'll tell you about in a minute or two. And I'm going to focus this afternoon on working with streaming data in Apache Ignite. I'm going to talk about how you can operate on it once as it's arriving into the grid. And I'm going to talk about how to get streaming data into Apache Ignite. So this is really the result of an exploration that I did over the past few months into working with Ignite. I used a product support use case where I wanted to bring different data from different sources into a single location so I could quickly run queries and drive activity, have notifications of changes. So I'm going to be talk about that use case briefly, and then I'm going to cover continuous queries in Apache Ignite for a few minutes. And then I'm going to talk about how I used my company's product, StreamSets Data Collector, to push data into the grid. And I've put demo there. I've actually going to ping pong between slides and demos all the way through to keep things interesting. So has anybody heard of StreamSets already? No, okay, wow. So StreamSets was founded about 4 years ago by veterans from Informatica and Cloudera. So they'd worked in this enterprise ETL space, extract, transform, load, and recognized that the tools of the time didn't handle the streaming use case very well, they didn't handle big data platforms very well, or NoSQL. And fast forward to today, we have our customer base about 50-50 big companies, small companies. I'll mention some of them later. And our core product, StreamSets Data Collector, is Apache 2 licensed open source. So we've seen, looking at our download logs, we've seen over 2,000 different companies downloading and over 1 million downloads of the different artifacts that we make available. One thing we've built over the past 4 years is broad connectivity to different systems. So I'll be using JDBC with Ignite, but we are able to talk to big data platforms on-premise, in the cloud, Kafka, other message systems. And our engineering team has a long history of working with these technologies. We have a number of committers and some PMC chairs from the Hadoop family of projects. So Hadoop Core, Spark, and Flume and Scoop, which are really the previous generation of big data ingest. So this is my sample enterprise. Okay, I've got an HR system that's running on my premises in a relational database holding my employee reporting hierarchy. So I just built a couple of simple tables in a relational database. Little more interestingly, I'm using a SaaS customer service platform for my support cases. Okay, my support tickets are there with their current status, their priority, the engineer that's working them, and so on. And I'm working with these devices, and I'm getting device status. Now, I'm going to show you a couple of different ways of doing this. One with just CSV files. So you can imagine you might be loading CSV files from some IoT system with device status reports. And I'm also going to have a look at ingesting directly from Kafka into Ignite. Now, there are a couple of reasons for bringing the data together into one place, into one in-memory grid. One is so that you can query across data sources. So you can answer questions that are not possible by looking at each silo. And another is being able to drive activity when changes happen. And this was the fascinating bit for me, was being able to push data into the grid and then be able to join the data from these different sources, from different caches, and provide notifications. So just as a level set, who has built Apache Ignite applications? A few. Who's used continuous queries? A smaller few. OK, good. So Ignite continuous queries, they're a mechanism that allow you to listen for modifications on the cache. And they're very, very flexible and quite efficient. They allow you to specify an initial query, filters that execute across the grid, listen for changes, and you can set things up with scan queries, SQL, and so on. And the really interesting thing is the execution takes place remotely on the grid nodes. So you run your application, and it actually ships code up into the grid to execute. Now, your local listener, where you can actually take action, executes in your application's JVM. And if you look at the documentation, you'll find that you can operate on, most of the examples seem to use Java objects, POJOs, and you can define a city object and so on. I beat my head against this for a little while, trying to get it working, and discovered that you can also use what are called binary objects in Ignite. So a binary object is a very generic object where you can say, OK, I've got a key, and then I've got some data that's in my cache. And the benefit for me was that I was able to ship lots of different data, fill up different caches in Ignite, and have generic code to read that data out. So I could literally say, OK, I've got an object key, and then a binary object that's got some keys and values as the data. And as well as being very generic, it's very performant, because I'm not marshalling data in and out of Java objects all the time. I'm just saying, OK, I've got a thing. Give me the name field on this thing. And then, as well as the basic running a query, getting updates, I'm able to run a transformer to actually extract data from whatever's in the cache and give it to me in a more consumable form. And I'll talk about that in a little bit more detail in a moment. So I hope everybody in the room is a developer or kind of close to a developer, because I'm getting down into the code. So when you're working with these things, you get a cache object in the usual way. This is like, I guess, Ignite 101. So here you'll notice that I'm getting a cache with, as I mentioned, an object key and a binary object value. So that's the most generic way I could find of doing this that let me work with a wide variety of data. And it's important that you add the with keep binary on the end of that when you get the cache. So that gives you a cache that's not going to try and marshal data in and out of POJOs. And then creating a continuous query, you have the same type parameters as your cache, because that's what you're working with. Now, optionally, you can create this initial query. And what the initial query does is it lets you set up a filter to get the initial state of the system. So you can imagine your application's working with data on the grid. It needs to populate some local state. And so what I did here is it's just a scan query, and I've kind of parameterized everything. I'm just saying, OK, if the data has a field with this name and it equals this value, then I want to know about it. So I just made a very, very simple scan query there. And then your application starts, and as things start to change, you need to be able to filter out the changes. OK, you can have like a null filter and say, OK, give me every change that happens in the cache. It's rare that you'll want to do that, because there's likely to be a lot of them. So you can filter those down, and you get this cache event. And this is where the Java Lambda syntax makes things very, very concise, which is nice, but it can be difficult to see what's going on. But basically here, I'm setting up a factory that gives me something that's going to process an event. And then on the event, I'm saying, OK, if the value of this field equals that value, then, again, I want to know about it. It's basically the same as that initial query. So this code, and you'll see this, I put these prints in so we can actually see it executing, executes in the cluster on the Ignite node, even though it's just defined in your application. Now, your local listener is where the action takes place in your actual application. So your local listener is going to get those filtered events and give you the cache records and let you operate on them. So here, I kind of broke it out as an example. I get the key of the object that changed. I can get its current value. And I can also see what kind of operation it was, so the event type. And then for updates, is older value available will be true. And I can get the previous value as well, and then go on to do whatever I want to with those particular updates, changes. Now, once you've set all that up, so everything I've talked about is basically just setting queries and filter factories and listeners. Nothing's actually happened yet. I've just registered these into the query. When you run the query, you get back a cursor. So that cursor is to iterate over that initial query. And so you can iterate over those results. And then this bit's really important because I was having terrible trouble figuring out how to get this working until I realized my app has to stay around. Because I was kind of doing the processing, the initial query, and then it would just like stop working. And I realized, I've got to keep my thread going here. And in a real application wouldn't just like loop sleeping. You'd probably be doing some more useful work. But yeah, you've got to actually stay alive. So I've got a little demo that shows you this in action. So let's go over to, oops. OK. So what I'm going to do, all on my laptop, is going to start my Ignite node. I've got a persistent database, so I should have some data there. And I'm going to start the SQL line. And I'm using the thin JDBC client here. OK, so what I'm going to do, I've got my demo application. So like I said, I wrote like very, very generic code. And so I can say to my application, listen on the city cache, and I want to know about cities whose name is London. And if I go in and look at the city table here, select star from city. I've just got 4 to make things manageable. I've got the city name and population. So what we should notice is when this starts, does its little handshake thing. OK, so it only tells me about one city, which is London. Just to get that up. And the reason this is really interesting is I put in these little prints so I can see this code executing in the grid on that Ignite node. So applying the initial query predicates to all 4 rows. This is why I didn't put like 10,000 rows in so that we could actually see them. And I can see that it's filtered out and only returned me 1 to my actual application. And then if I mess about with New York's population, so what is it currently? 700. So let's see, somebody gets born in New York. Then again, we've got another cache entry event filter. So that was the initial query. This is the event filter. But because it's not London, nothing arrives in my app. But then if we, unsurprisingly, if we mess with London's population, then 8, 9, 7. Again, we get that cache filter. This time, it finds something, and I get the cache entry with the ID was updated, and I get the old and the new population. So this is really nice. This allows us to monitor the cache for changes. We don't have to poll with queries. We can actually be event-driven. This is what I was looking for when I started using Ignite. Okay, so that's the basics. Come on, flip across. Seriously. Now, there's a variant on this. You can imagine that if your cache has, well, the previous speaker in this room was talking about having 1,500 columns. And some of those might be quite big. This might be much more data than you want to ship around the network when there's a change. You might be interested in one column or a handful of columns. So you get the ability to define a continuous query with a transformer. And what a transformer does is filters down what's sent across the network. So you'll notice that there are 3 type parameters now. So I've got my key and my value, but also the type that I'm going to send in the notification. So when I set up my remote transformer, what it does is it reduces the event. So I get an event, I can get the value, and then I can just reduce it to what I need. So here I've got a string that I want to get. So whatever field name I've configured in my generic app, I'm going to send back the value of that field to the client. And then the app, instead of getting the whole cache entry event, all it gets is a string. So it can just iterate through whatever it's just received and just like print out the string. And this is like really, really nice because now I'll just kill that app. So all I need to do is say population is the field that I'm interested in. So it's the same app, it just uses the query with transformer, it does the same query. But now, if I start messing with population on London, if I go to this side, I've got my 4 query predicates on the existing data. I've got my event filter to say, yes, I'm interested in London. Now I apply a transformation to that binary object so that all my app gets back is London's population. So really, really efficient for shipping that changed data around the network. Okay. So talked a little bit about what we can do with data in the grid as it's changing. Why does that thing keep coming up? Bear with me 1 second, apologies. Let's kill it. How many years have we been using projectors and still? Come on. Right. So I learned a lot from writing this couple of 100-line generic application. One is that when you are setting up these remote filters and transformers, you have to enable peer class loading enabled, because what's actually happening is you're shipping code out of your app into the Ignite node to be executed remotely. When you start creating tables via SQL and then trying to use them from the Java APIs, you'll notice that the names get munged on the way through. So if you can create a table called city, and then you have to refer to SQL_public_city, until you realize that you can override that by setting the cache name explicitly. As I mentioned earlier on, binary objects make your life simpler and faster. If you don't need that mapping into an actual Java class, if you're working at a more generic level, they're very, very useful. And I actually worked from the documentation pages and then discovered cache continuous query example on GitHub, which was very, very helpful. Okay, so that's the Ignite side of working with data that is constantly changing. This is the tool that I wanted to integrate Apache Ignite with. So StreamSets has a platform for data operations. We can build data pipelines that read from a huge variety of different sources. So as well as relational databases, APIs, IoT data, we can read firewall and proxy log files. We can do change data capture from databases like Oracle and so on. And what we're usually doing is reading that data, applying some transformations, so filtering data, enriching it, doing lookups and so on, and then writing into any number of platforms, usually for analysis. Usually what's going on here is that we're pulling data into Hadoop, S3, Apache Kudu, search indexes like Elastic or Solo, or even just sending it via Kafka to some streaming application. And then, like downstream, we're enabling a whole bunch of different analytical tools that operate on the data once it's there. So this is like super enterprisey and complex. And the way I like to think about StreamSets is as a Swiss Army knife for data. We've got lots of connectors that let us plug into different kinds of data sources and destinations. So this is how I started working with Ignite, trying to push data in. So my goal was I have some device data in a CSV file, and I'm going to read that from disk, and the file has this kind of pretty terse structure, you know, CSV data, and I want to apply transformations before I write it into Ignite via JDBC, and ultimately it's just going to be a standard SQL insert that's parameterized, pushing the data in. And I'll go through these steps in a little bit more detail in a minute or two. But the key ingredient here was the Ignite JDBC driver. So for loosely coupled Java applications that know how to work with relational databases in a very generic way, the JDBC is basically the mechanism. Now, guided by the documentation, I picked up the thin driver. So the thin driver is essentially a very lightweight handful of classes that communicate with the cluster via a wire protocol. So you don't have any kind of local copy of the data in your application. It's all just queries via the wire. And you need to bring in the Ignite core, whatever version .jar, and then use the JDBC URL. You say Ignite thin, and then you can give it the host name, the multiple ports, multiple host names, the schema, and so on. So there were some gotchas I discovered in this process. One is that when tools query metadata in Ignite, you have to use uppercase. And I actually identified there's a match expression in the Ignite code that is case sensitive where it should be case insensitive. Because if you ask for the columns from the city table with like uppercase city or lowercase city, you should get back the same list of columns. But what I found is that if you ask for lowercase city, you get back nothing. So I filed Ignite 9730 for that. And then actually, as I was kind of getting to the end of this process of working with this, I kind of knew there's a JDBC client driver which creates your own local copy basically creates your own local node co-located with your application, with the grid data in. And it's more mature than the thin driver. So there's a bit of a trade-off here. Thin driver, very lightweight, uses a wire protocol, doesn't suck all the data down onto your local node, but it is a little newer than the client driver. So let's see how it's able to ingest data from CSV. So this is where I have to start saying my prayers to the demo gods. All right. So I have some data. So it's pretty dull in that most of it says 0 for the fault code, which is like there's nothing wrong. Occasionally there's a number, a digit that's non-zero. And I want to get this into Ignite, but I don't want all the extraneous 0 stuff. So this is StreamSets data collector. So it's like an IDE for building data pipelines. I get to say where my files are, the pattern, the fact that they're delimited, so CSV format, and they have a header line. And then I get to transform the data in a number of steps. So my faults in Ignite, they don't have a natural key. They've got a timestamp and a fault code and a serial number. So I assign a unique ID per record. So I create a field called ID. And then everything that comes in from CSV is just a string, and relational databases like to be strongly typed. So I convert into a date time and an integer there. And then I can get rid of all the 0 fault codes. I can just drop those in the trash and just send anything with a non-zero fault code and do, this is, so that was filtering. This is enrichment. I've got some data and I want to enrich it. And what I'm doing here is a lookup just in a static table with different fault codes. I could be reading another database or a Redis cache or something like that. And finally, I'm writing the faults to Ignite through that JDBC driver. And again, mapping. So you'll see here, uppercase fault. And I have to map all the columns because they all need to be uppercase. This was quite annoying, but there you go. Bugs and software, they go together like apple pie and custard. So if we reset everything, so what we should see is the data going into Ignite. And you might think, oh, this is like pretty dull because every database tool has CSV import, and we know how to do this. But this is a continuously streaming pipeline. I've got 86,400 records here. If I go and kind of, let's see, unhide one of my, hang on, MV, I hid a file here. If I create another CSV file here, what happens is it notices that the new file's there in a sec, there you go, and it pulls this in. So files can be landing in this directory and being ingested continuously into Ignite. Well, another thing that I can do here, I should have done before, I can see here that there's only 1,700 non-zero faults. I can see the balance here between what's been discarded and what's been sent. And also, as I'm building the pipeline, I can get a preview and say, OK, just read the first 10 records and then show me as we go through what's gone on. Show me the unique ID that you assigned, that string conversion that happened. Show me the filtering, the fact that most of them go to the default and one goes up here. And then show me that fault that was set, critical fault, fault code number 1. So I've gotten data into Ignite, and now I can go and query it and say, OK, select star from fault. I can get 10 faults, and I can do more interesting queries, such as select faults by type. So, you know, stuff that standard relational database stuff, but it's there in Ignite and it's super fast now. Now, so far so good. Not totally world-shattering, reading CSV data into a database. Now I want to bring this data together from my different systems. I want to read from something more interesting than CSV. I want to read from Apache Kafka. I want to replicate data in from a relational database. And I want to read support tickets from Salesforce. So fair disclosure, I worked for Salesforce before StreamSets, so I know their APIs for getting support tickets from Salesforce Service Cloud. But you could use Zendesk or whatever other SaaS system you were using. So let's take a little tour of some different systems. So we go to, so here's the Kafka version. And you'll notice this is just the same. All that's changed here is that I'm reading device faults from Kafka instead of a CSV file. And I'm parsing them out of JSON. But because they're parsed in that first step, everything afterwards is exactly the same. All my tools for transforming the data can be used in exactly the same way. So if I start this, and let me just go delete from fault. OK, so we cleaned out the fault table. Yep. And then what I'm going to do is I'm going to ram those 86,000 faults through Kafka as fast as I can. So this is just like, what a rookie mistake. Bear with me. I should have been watching that monitor, not this one. Apologies. OK, so you didn't miss a lot. This pipeline is exactly the same, except it's reading from Kafka. I just sent 86,000 JSON faults through, and yeah, they were read in like a second or two. What I can do with Kafka that's really nice, I've got a script that lets me slow things down to a more human pace. It just puts a bit of sleep into the system. And there we go. So we can actually see the number ticking up now. And we can get a snapshot. So we can scoop a batch of data out of the pipeline, capture the snapshot. And then you can do this on production systems. You can scoop out the data and say, OK, let's have a look at that data. And let's look at how it was transformed going along the actual pipeline here. And yeah, usually everything is the zero fault code. But yeah, you can diagnose your pipeline like this. OK, so we're reading data from Kafka. We could let's just leave that running and read some relational data. OK, so over in MySQL, I've got an employee table, and employees have got managers, and they've got there's a reference to a title table, and it's all normalized data. What I want to do is denormalize it and bring it into the memory grid, so that again I can query it very quickly. So what I've done here is I'm reading from JDBC, but I'm reading from MySQL, and I'm actually doing a join in the query. So I'm getting MySQL to do some of the work here and writing it into Ignite. So just writing into employee, mapping those columns. And then I don't want to keep doing this. I'm just going to stop the pipeline as soon as I've read all the data. So again, if I run that, it runs in like 0 time because there's only 17 employees. But it read 17 records. The extra 2 are the control records that say stop the pipeline. But now I have over in Ignite, I can do select star from employee. And again, I can run queries like the regular relational database things like, OK, who reports to Hannah Bates, these 3 engineers. Where it gets really interesting is when I pull more data in from Salesforce. So here, I'm going to read cases, so service tickets from, support tickets from Salesforce, and write them into Ignite. So again, it's very, very simple pipeline, but this one's really powerful because if I just reset things and then set it running, and I can actually go look at my Salesforce data as well. Oh, okay. Did I fall off the network? Okay. Obviously did not make the appropriate sacrifice. Whoa. Failed to send request. Okay. Okay, I'll talk about, that is really bizarre. This like literally worked earlier on today. Okay. Okay, so it's rather annoying. So what should be happening is I have 8 support cases in Salesforce. They would be written into Ignite. Let's just try overwriting the password there. Maybe I messed something up. Yes. Okay. Parameters. I'm not going to spend a lot of time diagnosing this. If it works, it works. Oh, that's so annoying. Right, for some reason, Salesforce is not cooperating. Okay, so what should be happening is that all of those cases should be going into Ignite, and I can run queries like which managers have engineers working high priority cases, which will give me back nothing right now because there's no data going through. Gosh, that's annoying because that's like the rest of my demo. What I can also do is I can change things here, and then I can change things in Salesforce. Those changes, StreamSets would be listening to the Salesforce streaming API, picking up those changes and pushing them into Ignite, with the result that I can actually have an app that listens for high priority cases. I have just no idea why this is not working, but you'll get a little extra break. So I must have fat-fingered something along the way. All right, I'll explain what would be happening. So, and a confession here. If you tried to do this and actually had the connection to Salesforce working properly, you'll find that it wouldn't work right now because I found another bug. So since I brought all this together, I've learned that the thin JDBC client is actually pretty new. There's some rough edges. So there's a bug, and actually an engineer was assigned today to it this morning. I got the notification. So Ignite 9606. When you ask the driver for the primary keys for a table, whatever the primary key column is, it tells you _key, which is not totally useful because you want to get like ID or whatever, and it just says _key. So I had to build an ugly workaround into our product code, into our JDBC consumer to get this working. So if the primary key equals key, then get it from the primary key name rather than the column name. So that's not going into StreamSets. So, but the good news is that it looks like they're working on fixing Ignite 9606. So you'll get the benefit of my diagnosis there, I guess. So the application I wrote was to listen for high priority service tickets. Because what I can do is I can have that continuous query filter on tickets with priority equals high, and then just give me back the serial number of the device, and then get the last 10 sensor readings. So you can kind of see the code here. The really nice thing here is it's almost, if you squint hard, it's almost like I'm joining data in two different caches. But what I'm actually doing is getting a notification from one cache and then running a query on another cache. So I set up this SQL query to get the last 10 faults based on the serial number, and that's parameterized. And then I listen for the serial number in the high priority cases, and I'm able to run that query in the local listener and print out those cases as they arrive. And that's exactly what I would show you if that Salesforce pipeline was working. Anyway, so I can't demo it, but believe me, it works, and it's super impressive because I changed something in Salesforce, and then this list pops up of the last 10 faults. It's just awesome. Anyway, I've been talking about pushing data into Ignite in this kind of narrow use case. It's almost like master data management, combining data from different applications to build like a master copy. Other use cases that our customers commonly use us for, one is the term is data lake replatforming. It's basically taking the data from your relational database and putting it into Hadoop or S3 or Azure Data Lake or whatever. And we have a lot of customers using us with IoT data. So that kind of device fault data is actually very common for shipping around. It's very rarely being created in the same place as it needs to be for analysis. Cybersecurity use cases, so those, again, firewall logs, web server logs need to be ingested into some analysis platform and are often operated in this is not a good conference to say real time, in near real time. Okay, things like fraud detection, intrusion detection, those kind of applications need a constant stream of data. Few of the customers that have been using StreamSets, GlaxoSmithKline, the global pharmaceutical, has thousands of pipelines running. They have drug discovery data siloed in many, many different relational databases that they need to bring into a central data lake so that researchers can do queries across the whole body of data. Cox Automotive is not a well-known name, but they're the parent company for Kelley Blue Book, Autotrader.com, and about 25 to 30 other automotive-focused websites. So you can imagine they have a lot of correlations that they can draw, a lot of insights they can draw between data from those different properties, and they have StreamSets running at every subsidiary, feeding their central data lake. And then Availity, a company in the healthcare technology space, and they were having real problems with their ETL process, just the length of time it took to find developers with these skills. And they found that using StreamSets, they were able to build data pipelines in a kind of a self-service way and save months of searching for development resources. So wrapping things up, yeah, continuous queries are a really robust notification mechanism for acting on data changes. The knobs and levers are there to scope down what you see in both filtering the changes based on the data and then filtering down the fields that you receive. I found the thin JDBC driver. I found a couple of issues there, but it was pretty useful in getting started. And then, yeah, Data Collector can read data from a wide variety of sources, including Salesforce, honest, and then write into Ignite via the JDBC driver. So there's some useful references there, and I've got about 5 minutes for questions. Yeah.
So how big can this handle? Let's say I have a database, maybe like a billion.
Yeah. So the question was, how big can it handle, say you have 1 billion rows? So yeah, you can work with 1 billion rows. Typically, the initial ingest will take some time, and then, yeah. So that's actually one of the areas we're working on is to partition the query there. Right now, it's a single sequential query. You can read multiple tables in parallel in a multi-threaded JDBC consumer. But yeah, that's somewhere we're working on, is that working with like large initial databases. Once they're there, we have mechanisms like change data capture for keeping up with the changes quite efficiently. Yeah.
If this table is updatable, which means there's some record will be updated.
Mm-hmm.
So how do you retrieve those updated records?
So the question is, if the source table is being updated, how do you retrieve it? So there's several mechanisms. The most blunt force one is you just read the whole table, which you don't want to do when you've got billions of tables. No. Another is if you have if you have, say, an auto increment key or a last updated time, you can run incremental queries, and we keep the last value of that column as an offset, and you can run an incremental query to just get those last set of changed records. So that's a good technique because it works through a standard JDBC connection. It's just standard SQL. And then the different databases each have their own mechanisms for doing what's called change data capture. So with Oracle, we use the log miner mechanism. With Postgres, we use WAL. With MySQL, we use the binary log. So the downside of change data capture is that each database does it its own way. But the upside is that you actually see the raw changes rather than running queries. But you know, it's something you need to investigate because there's also load on the database. So there's a load of trade-offs in picking which mechanism to use.
Okay, so the changes will be captured through, let's say, MySQL binlog.
Yeah.
And applied on the final data.
Right. So the changes will flow through the pipeline, and then you can push them into Ignite or wherever you like. Yeah. Yeah. We have people doing that with. Commonly it's Hadoop, but we have people doing exactly that. Yeah. Yeah. Yeah, I would look at. I kind of ran out of time as I was getting the content together, but I would look at the client JDBC driver, the other one. So it's a bit more work to set up because it actually creates a full Ignite node, you know, with your application. But talking to the GridGain people today, that's much more mature, and so you'll probably get a bit further. I was actually able to look at the code for both of them and see where the client driver was case insensitive, which is as it should be, and the thin driver was case sensitive, which was where the bug was, and I filed the JIRA. Okay, well, thank you very much. Apologies for the glitch, but thank you for coming.